Hello friends, welcome to Risingpearl.com. Today we're talking about series 13 where we're learning a great deal on surface areas and volumes. This is webisode number 14 and today we are going to continue to find out how to solve questions on surface areas of combination of solid figures. This is the part 5. So let's dive straight in. Now we have been talking about what are the three-step strategy in solving these questions. So we want to first quickly visualize which simple solid figures make up our given complex shape in the question. That is, by simple solids we mean cuboids, cubes, cylinders, cones, spheres, hemispheres, etc. Step 2 is that we find out which areas we want to actually add or which areas we want to subtract, or it could be a combination, some we add, some we subtract, to get to the required area. We find that out in our step 2. And final step is really calculate the actual areas of these individual solid figures by using the formula, because again remember that we know the formula to calculate total surface area and the curved surface area for each of these cuboids, cubes, cylinders, cones, spheres, hemispheres, etc. So using those formulas we compute individual areas that we need, and then using step 2 we find out which areas add and or subtract, and that is how we calculate the required area. So these three steps we always use whenever we solve questions involving combination of solids. Let's take a look at a question number 7. We are using a running total because all of these, this is the part 5. From part 1 we started looking at different questions. So continuing with the same running count. So let's read the question. From a solid cylinder whose height is 2.4 centimeter and diameter is 1.4 centimeter, a conical cavity of the same height and diameter is hollowed out. So we start with a solid cylinder and then whose height is given to us and whose diameter is given to us. Now from that solid cylinder we actually take out conical cavity is hollowed out. That means we cut a cone out of the solid cylinder. Now find the total surface area of the remaining solid to the nearest centimeter square. So if you were to just draw this, so we are going to draw first the solid cylinder, and then what we are going to do is we are going to actually cut out a cone from the solid. So our final solid will look like this. So we started out with a solid cylinder. So this is our solid cylinder, right? And then what we did, we actually carved out this cone. So this is the cone. So we started out with this, and then from here we actually carved out this cone. So this piece we actually took it out, and then we are left with this. So our final shape looks like this. Now what is given, it is important to note, is that this height is given to us because we know the height of the cylinder. This height is given to us. Also this radius, the radius of the cylinder R is given because the diameter is given, so R is given. And now the cone exactly matches. The cone has the same height and the same diameter. So the cone exactly fits inside. Now maybe instead of carving the cone out this way, you could have actually gone the other way. You could have said maybe this is the top and this way you could have carved it out. It does not matter, you will get the same answer whichever way you actually carve the cone out of the solid cylinder. So it's important, friends, to understand visually in your mind what exactly is the question, how our final shape begins with, and what we are taking it out, and how our final shape should look like. So now that we understand this, let's find out. So we have to find out the total surface area I should say, of the remaining solid. That means, so let's clean this up a little bit. So the total surface area of our final solid should include the curved surface area of the cylinder, because remember, whenever we talk about the total surface area, we always tell ourselves, so what is the surface area on which I have to apply paint. If I were to paint this, what part of the total solid do I need to put the paint on? So clearly the entire curved surface area of the cylinder, right, all around you have to apply the paint. Then we have to actually apply the surface area of the bottom part of the cylinder. So the blue, which is highlighted all around the cylinder, we have to apply the paint, plus we have to apply the paint to this bottom circle, the surface area of the circle, right? And then finally we have to apply the paint on to the curved surface area of the cone. Again, remember that if you look from the top, right, you will see like a cone which is cut out. So you have to apply the paint on this as well. So the surface area will include the curved surface area of the entire cylinder outside, plus surface area of the bottom circle, plus the curved surface area of the cone inside the cone, right? This is the curved surface area of the cone from inside. You have to paint, you have to apply paint on all of these places, right? And which is the curved surface area. So here, everywhere. And that is the curved surface area of the cone. So total surface area that we have to find out is going to be curved surface area of the cylinder, surface area of the bottom circle, and curved surface area of the cone. So now using the formulas that we have learned, so what we know is that this height is given to us, right? And this radius is also given to us. So curved surface area of a cylinder, formula says it is 2 pi r times h, or it will be 2 pi, what is r? So r is equal to 2.4 is the diameter. So we know that it is diameter by 2. So we can say r is equal to 2.4 by 2 times what is the height? Height, actually r is 1.4. I made a mistake here. So this should be 1.4. This is 1.4 and height is 2.4. So this is 2.4. So you can actually find out. So let's say this is x1. You can calculate the value, and I will urge you to actually don't compute the value fully. Keep this in terms of some value times pi. Keep this in like something times pi. Don't try to put 22 by 7 and actually try to solve it, because at the very end you want to have all of the numbers, if you can, in terms of pi, and then do the final computation at the end. You definitely want to, at least solve this and bring it to some number or a fraction times pi. So let's say this value is x1. This is the curved surface area of the cylinder. This is our first component. We know that we have 3 components. Now let's move on to the second component, which is the surface area of the circular base, right? So if this radius is r, this is also r. So the surface area of any circle with radius r is pi r square, or they should be pi times r is, this is the diameter, so 1.4 pi 2 times square, pi r square. So let's say this value is x2. So whatever the value is, I mean, as you can see, quite simply this will be, so this is going to be 0.7, so it will be pi times 0.7 square, or 7 sevens are 49. It will be 0.49 pi, right? So this will be x2. And then finally we have now the curved surface area of the cone. So for the cone, important thing is the formula actually is pi r L. So what is L? L is actually this length. So from here, let's do it here. So from here to here, this length, that is the slant height, this length is L. Now what is this length? We know that if we take a if we take a plane, we will get a right triangle, right? So if this is R and if this is H, we know that applying Pythagoras theorem, L square is equal to R square plus H square. So this is R, this is H. So if we calculate this, we are going to find out L, or L will be equal to square root of R square. R is actually 0.7 square plus H is actually 2.4 square. So this is the value of L, and curved surface area of a cone is pi RL. So this will be pi times R is 0.7, which is 1.4 by 2, times L, and this is the value of L. So let's say this value is x3. So we know we have found out the three separate areas using different formulas, one by one. So if we look at our question now, so the total surface area that we have to find out is nothing but sum total of curved surface area of the cylinder plus surface area of the bottom circle of the cylinder plus curved surface area of the cone. So we have found out x1, x2 and x3. If you simply add them, you are going to get the final answer. And it is at this step that ideally you would want to expand the pi either as 22 by 7 if it is given in the question, or use it as 3.14 and then find out the final answer.